So people, welcome to the walkthrough for the Edexcel. It's the GCSE, so be careful on that front. It's the Unit 2H, so it's paper 2. All calcs are allowed and we're in January 2019. Here we go. So, question 1. Just simply converting, not a bad way to start an exam here. So, very wordy though. End of the day, meters, answer in centimeters, get it converted. So the idea is that in real life and to the scale factor is multiply and divide by 200, depending on which way around you're going. We are going from real life and we are going into scale. So it's divide by 200. Grab your calcs. It's 36.5 centimeters. Number 2, bog standard nth term. It's an arithmetic sequence, so it's just n's, not n squared. As soon as you spot it's going up in 4s, write down 4n, because that's going to be part of your answer. And if you compare your sequence, if you compare your sequence to the 4 times table, it happens to be higher by 3. So we need to add 3. Number 3, typical over-the-top wordy. Read it if you want, I don't bother. I just go one line at a time. So top line, only thing that's important is 90. Each counter in the bag is either. Now I'm never a fan of sentence and sentence. Get your work organised. Red. Blue is 2 to 13. Going to put some more red counters in the bag. Now it says some. All right. Some more red counters. So the probability of taking a random red counter is 1/3. So we come to that second because actually 2 and 13 mean 2/15 of the counters are red. If you times that by 90, all right, 2/15 times 90, we're getting 12 red counters. And to balance that up, 90 minus 12 means 78 blues. Now we come to this sum. If you put some more red in, you'll have 12 and a few more. You'll still have 78 blue. But now what you will be able to write is the probability of a red counter is 1/3. Now the probability of a red counter is the number of red counters you've got divided by the number of counters you've got, and that is 1/3. So although it started off wordy, ratio and fractions, it's actually an algebra question. It's setting up and solving. So let's times both sides by 3. And then multiply both sides by x plus 90. We're only timesing by 1, so who cares? Subtract an x from both sides, whilst subtracting 36 from both sides. And there we go. We've got our value for x. Venn diagrams. So usually they've drawn the circles for you, but not here. Bit tight really, so always make them as big as you can. It's very easy to make this a small section and you end up having to put 7 numbers in there, so always make it big enough to squeeze at least 3 or 4 numbers in. And it says we're only dealing with the numbers 1 to 12. Okay, tick. A is odd numbers. All right. A intersection B is 1 and 3. A union B means all the numbers need to go into A or B or appear in both. So let's run through them. So 1's already done. 2 is even. Can't go into A because A is odd. 3 is done. 4 is also even. 5 hasn't been thought of yet. 6 is even, has to go over here. 7 hasn't been mentioned yet. That's an odd. We've skipped 8, so 8 must be outside the zone. It's not in A or B. Whoops, should really put A and B on there. We've got 9 must appear in these two circles. Well, it's odd, so it goes into A. 10's been missed, so goes in the outside zone. 11, that's got to be in these two circles. Well, it's odd, so it has to go there. 12 is even, so it has to go there. Yeah, it's a strange way of wording those, but take your time. 4 marks, bit of a goldmine, really. So number 5, I thought it was quite a nice question. It's quite an interesting way of going about it. I will just say, spoiler alert, it's ultimately a bit of a simultaneous equations question. Now, why is that? Because it says the tiles are identical, but you don't know their length and you don't know their width. So let's refer to that as x and that as y. So let's now write an equation for this distance, which is equal to 123. So if we walk that distance, we've got an x, another x, another x, another x, and a y. Let's do the same for the vertical. We've got an x and another x, that's 2 of them. We've also got an end, in other words, a y. So it's gone from a shape question to actually a very easy simultaneous equations question. Top takeaway bottom, the y's disappear. We've got 56, so we get x to equal 28. And don't forget, you need y as well. Well, 2 y's are 56 plus y, sorry, 2 x's, 2 28s are 56, plus the y has to have a value of 11. But we haven't finished. Work out the area of the shaded rectangle. Now, if we look at the length of this rectangle, that's 28, that's 28, that's 28, that's not. But it's not 11 either. It's actually 28 minus 11. So it's 17. Let's think of the same vertically. That's 28, but same again. This is actually 28 minus 11, 27. So the rectangle, if you add the length and width up, the actual rectangle that's shaded is 101 wide, 45 high. You grab your calc. It's 45, 45. 4,000, that's a rubbish 4,545 centimetres squared. Number 6, so the highest common factor. It's not the worst numbers in the world, so if you want to make a list, simply list them and find your highest number. But it's always good revision. Do your factor trees. Split it any way you want. I went for 12/8, and I like to do 3-way splits to speed the process up. 3 times 2 times 2 is 12. 2 times 2 times 2 is 8. That can be 12 tens. That's obviously 5 2s, but again, 3-way split. And the highest common factor, is multiply common factors, just get them paired up. So we have a 2 in both, there's another 2 in both, there's another pair of 2's in both, and there's a 3 in both. There's no others. Get them times, we get the HCF to be 24. Question B, little bit weird. Now, they've given you space down here. If you wanted to do it, some teachers love the Venn diagram method for this, and it's perfectly fine. I would just argue a bit too much work for 2 marks. You simply want to look at what you don't need to multiply. So let's go up. Let's go in ascending numbers. Let's start with the 2's. 2 cubed goes into 2 to the 4. So when it comes to 2's, that's the highest power required. When it comes to 3's, 3 only appears in C. That needs to be included. That would be in your single things out there. When it comes to the intersection, don't forget, you don't do 2 cubed times 2 to the 4. The 2 cubed goes into 2 to the 4. You'd have a 2, and a 2. That's why we're not manipulating or working with 2 to the power of 7. On to the 5's. That 5 goes into 5 squared, so we don't need a 5 cubed. You just pick that. Let's do the 7's. Same with the 7. That 7 goes into 7 squared. We don't need a 7 cubed. And 11, we only need one of them, because that would, for example, be in a crossover down there. Then you reach for your calculator and you get the interesting, shall we say, answer of 646,800. There we go. Number 7, though, back to good old standard maths now. We have capital. We have percentage. So if you're earning interest, it's a 1 point. It's going up, not down. 2% would be 0.02. So you need the 3 on the end. We need the answer to the nearest dollar. Your calculator should say 9,100.09 on and on and on. So nearest dollar, 9,100. Next part though, part B. It's one of those questions where you do not know the original amount. But you do know it got timesed by 1.15. Because it was an increase. And then it was a decrease. It got multiplied by 0.92, and we ended up at $687,700. You've got to work it back to 2015. Yes, folks, it's a reverse percentages question. Reverse the flow on your calc. Start with the 687,700 and divide by 0.92, then divide by 1.15, and you get the reassuringly nice round answer, 650 grand. Seems extremely reasonable for an answer. If it was a weird answer, you'd go, think I've done it wrong. On we go. As soon as you see the words mass and density, I don't carry on reading. I write down DMV, work out the volume. So volume is mass divided by density. Just check, by the way, kilograms, kilograms. There isn't a conflict of units. We've got meters cubed, meters cubed. No need to muck around with units. We can just go straight for 3.5 divided by the density of 0.65. Don't forget to do as you're told, 3 sig figs. Our calcs should say 5.3846 and so on. So 5.38. So you've got this speed, 630 kilometers per hour. it wants it in meters per second. So let's just rewrite it. Let's change kilometers, times it by 1,000, and there we go. We've got 630,000 meters per hour. But while we're at it, let's change the hour as well. Times it by 60 for minutes, times by 60. And there you go. You're nearly there. You've changed it from kilometers per hour into meters per 3,600 seconds. But what does meters per second mean? It means we don't want how far it travels in 3,600 seconds. We want how far it travels in 1. So we've got to divide by 3,600. We get a nice 175 for our answer. Number 9, even though it's kind of already come up, they've thrown simultaneous equations at us again. Your choice. Do you want to make the y's the same? Me personally, no, I'm going to go for the x's. So let's have the top equation staying the same. Bottom equation, we're going to double everything. Double the x's, double the y's, double the 9's. And the x's will disappear if we subtract them. So use your calculator at this point if you want. -2 take away +5 takes us to -7y. 18 minus 4 gives us 14. Divide both sides by -7. We get the value of y to be -2. I'll pick the bottom equation. 2x's minus -2 equals 9. Subtract 2 from both sides and we're there. 2y is 7, so y is 7 over 2, or 3.5. Question 10. So whenever you're doing an equation of a line, your brain needs to think y equals mx plus c. The plus c is always the easy bit. It crosses at 1, so my answer will have a +1 on the end. The only question is what number's going to go in there. Let's get rid of the underline in case it's a fraction. So many. How do we find it out? Find a sensible triangle. That could be one. I say sensible because it goes through the vertex of each corner of the square. You don't want to pick any halfway, third of the way. No guessing numbers. So that would have been a good coordinate to pick. And to find the gradient, however big a triangle you've drawn, it is the height of this big one has a height of 6. It has a width of 4. So the gradient is 6 over 4 or 3 over 2 or 1.5. On we go. Now, with wordy questions, I always refer people just in the link below the video. There's a link to my homepage of these Edexcel Higher IGCSE papers. On my WA papers, my worked answers, you might call them annotated papers, I always do full reasons. So I've written these out perfectly already. On here, I'll just talk you through them. So, job 1, compare the medians. So you need to simply say, on average, science results were better or science results were higher. That will get you the tick. And for comment 2, comment about the range. But put it into context. What does a higher range or interquartile range means? If you have a higher range or interquartile range, then it means the results are more spread out or they are more varied. Try and get those keywords in. They're what examiners are looking for. Some indices. So, anything to the power of 0 is 1. Get it learned. Part B, power to a power. So do things in turn. We've got a number 3. We've got to cube it. 3 times 3 times 3. Now, when you do the x's and the y's, don't forget it's the power to a power. And so the rule to simplify them is you multiply the powers. So we've got x squared cubed. 3 times 2 is 6. And for the y's, 5 times 3 is 15. Question C, bit sneaky this one. It's one of those called difference of two squares. Don't forget, anything which starts off like square number minus square number, in this case x squared, it factorizes to x plus 4 and x minus 4. This is a sneaky one because look what happens when you take a 2 out. I bet there are some people who would have stopped there because the only thing those terms have in common is a 2. But I'm afraid not. They are e squared minus 3 squared. So it's e plus 3 and e minus 3. That would have only gotten you a mark. That's where the 2 marks come from. Question D, transposition of formula, rearranging or changing the subject, whatever you call it, always do opposites. So get rid of that square root. Square everything. Left-hand side becomes that. Right-hand side, it disappears. Let's get rid of the denominator. Multiply both sides by 5r. I'll cheat here because I run out of room with my electronic pens. If we want to make r the subject, we've got to get the r's on the same side, because when r is in more than one place, you have to isolate them and factorize. So take the r out. 5m squared minus 1. We're nearly there. So to be able to write r equals, we now divide both sides by the brackets. Lots going on there. Very chunky sort of 4 marker. Very much towards the top end of rearranging formulas. Well worth revising. Seems to come up on pretty much every paper. The only thing we don't know, will you get an easy one or a tricky one? Will you get a 1 or 2 marker or a big meaty 4 marker? That's the bit we don't know. Number 13, there's an X in the way. Well, carry on as normal. If I asked you to find the mean, you would multiply. So get on with it. Even if you're not 100% sure of how to go about this question because it's new to you, at least do this so you get a mark. But when you come to multiply the x bit, carry on as normal. 7 16s, 112, 8 x's are 8x. Now that x is blocking you, but just think about this. Firstly, we don't know how many are in this survey. So let's just add up. So frequency, we need to add these all up. All right. We do not know how many things, how many mice are in these nests. So add up your frequency column. We get x plus 39. Add up your total. We get 8x plus, and all the numbers make 264. But here's the key. To find the mean, you do total here, 8x plus 264, was going to write a 5. That's our total divided by total of the frequencies equals the mean. I mean, it's come up already, one of these. It's come up again. Let's multiply both sides by x plus 39. And let's rearrange. So, take away 7x from both sides. Nice. We end up with an x. When you do 7 lots of 39, you get 273. We're now going to take away 264. Bosh, we have a 9. Job done. So the x might have caught people out. My advice is always just carry on as normal. All right, just carry on as normal. How do you find the mean? You do a divide. Carry on. Right, number 14, probability trees. So if the probability of a win is 0.35, we can fill in everything else. It doesn't give us any reason in the question for why the probabilities may change, so they don't. 0.35 on the top branch, and on we go. Work out the probability that Marcus wins at least one of the two. So top is win-win. Next one is win-lose. That's at least one win. Bottom, so down then up, is also at least one win. So you've got a choice here. You can either get on your calc, press 0.35 times 0.35, add it to 0.35 times 0.65, add it to 0.65 times 0.35, or I'm going to do 1 minus lose. Because don't forget, at the end of your branches on probability trees, they should all add up to the number or value of 1. On my calc, no matter which way you've done it, no one really cares. By the time you've found a shortcut, sometimes you could have just done a question the long way. But either way, as long as you get 0.5775 or whatever the heck the fraction equivalent is. Trapezium. It's one of those you're expecting numbers on. Why is there algebra, etc., etc. It looks like it's tricky. Go back to basics. How do you find the area of a trapezium? The area of a trapezium is a half of the parallel sides added together. So let's add them together. We've got an x and a 3x, a positive 5 and a negative 2. They simplify to positive 3. So that multiplies by the height, the distance between them. That's how you find the area of a trapezium. And we can say that the area is 133. So not to do too much at once, I'll expand the brackets first. So 4x times 2x is 8x squared. 3 times negative 3 is negative 9. Now I do my x terms. That loop is positive 6x. That loop is negative 12x. 6x minus 12x. I'm into minuses. Let's get rid of this half by doubling both sides. That means we can get rid of those brackets. And we're nearly there. You can sort of keep one eye on what it was asking you to show. We now subtract 266 from both sides. and you get the magic 275 that they asked for. So on to part B. Now, bit of advice for exams. You'll notice B says find the value of x. Only says value, so one answer is not going to be valid, but it's rarely saying solve that. So, hint for the future, just because you cannot do part A, don't let it block you from having a bash at part B. Because let's say you didn't get part A, you didn't understand it. Well, part B is simply saying to you, can you solve that? Now, I've got to be honest, if I was trying to solve it, it might factorise, but the big numbers. If you've watched any of my other videos, if it's prime numbers all over the place and small numbers, I think they're easy to... This one's not. If you do the AC method, 8 times negative 275, it's getting into stupid numbers. I would use the formula all day long. A is 8. That's a rubbish 8. I'm rubbish with my 8s. B is minus 6. C is minus 275. And get on with the formula. So even if you can't do A, you should be still having a bash at the formula for part B. 6 plus or minus B squared is 36. We've got a minus times a minus. And for the 4AC, 8,800. Now 6 minus everything, you get a minus 5.5. Now if you think back to the answer, it can't be minus 5.5. That would mean the top length would be negative. You don't get negative lengths. So we reject the negative answer, which is why it said value. The only answer we accept is 6.25. On we go. So we've got the old volume, surface area and linear scale factors. So let's just work out the scale factor for volume. Volume scale factor. And it depends which way round you're going. You could do 960 over 405 or 405 over 960. I don't care, as long as you're clear that if you have a number bigger than 1 or smaller than 1, you take care as to which way round you are multiplying and dividing. Although diagrams are not accurately drawn, they cannot be drawn to mislead you. So B looks bigger because it is bigger, and so on and so forth. So I'm going to work it with the 960 on top. Now, when you stick it into your calc, it'll cancel it down for you. This cancels down, if you've got it upside down, to 27 over 64, but 64 over 27. And they're nice because they are cube numbers. Because the key to this question is the knowledge that if you know the volume scale factor, that's the three-dimensional scale factor, you can cube root it to find the linear scale factor. In other words, cube root the top, cube root the bottom. But you'll notice it doesn't want linear, doesn't want height or radius or anything, because that'd be important. We'd use the linear scale factor if we were doing ratio to ratio or height to height and doing frustums and stuff like that, but we're not. So we need to go to area scale factor by squaring the top and squaring the bottom. So B has a surface area of 928. I want to make it smaller, so I need to divide by my number that's bigger than 1. And it spits out a reasonably well-looking, healthy 522 centimetres squared. On we go. Good old functions. Starts off okay, gets a little bit, in the... But there we go. I think this is a decent functions question. Could be a lot harder. F of 3.5, either do it mentally or on your calculator. It means 4 minus 15 for minus 11. G is the function. Now don't forget, what does domain mean? Domain are the x's. You'll see a lot of domain and range if you go on to do A-level maths, but essentially think of domain as your inputs. They are your x values. Now there are always certain things you don't want to do in functions. One of them is square root a negative. That will cause an error on your calculator. Also, you don't want to divide by 0. We do not want this to equal 0. We do not want it. Now, if you add 2x to both sides and halve it, in other words, we do not want x to be a half. Because if it is, you're doing 1 divided by 0, and that's when math starts to not go so well for you. Anyway, it's only worth 1 mark. Just need to put the half as the answer. On to part C, so it's compound functions. You always work inside out. So this means sub negative 1.5 into G. So you get 1 divided by 1. It's minus a minus, and it's 2 lots of 1.5. So in other words, people, you're getting the answer of a quarter. Working inside out, that means you now need to put the quarter into the original, and you've already done this for part A. In it goes. You need to do 4 again, mentally or on a calculator, no one cares, but it's 3 lots of a quarter, or in other words, 3 quarters. And 4 minus 3 quarters is 3.25 or 3 1/4, or what's top heavy, 13/4. All are acceptable. Number 18. I don't read these questions until as soon as you see lower bound, get cracking on with these. So x is 8 to 1 sig fig, so go up by half, down by half. A is 4.6 to 2, so go up by half, down by half. M is 20, correct to the nearest 10, up by half, down by half. Whoops, it's 20. Come on, people, help me out here. 20, up by half, down by half. There we go. You never saw that mistake. Now we can focus on here. We want the lower bound, so we want P to be as low as possible. Now, the way it can be as low as possible is if we have the smallest possible numerator divided by the largest possible denominator. So we want m minus x to be as big as we can. So we want m to be as big as possible and subtract the smallest possible x. So now it's just a case of picking from your menu. Smallest a, 4.55. Biggest m, 25, minus smallest x, 7.5. Stick it all in your calc brackets if you need to. I get 0.26. They take the time then, but I think they're nice questions. Go up and down by half. You've got a menu to pick from. Not a bad question, just lots of effort required. So we have a histogram. It says work out an estimate for the proportion who waited longer than 20 minutes. So longer than 20 minutes really means what fraction of people out of the entire histogram are up there. Now it tells you no frequencies. Frequencies on histograms is given by area. So your job, grab your calc if you need to, you need to find the areas of all these bars. And area is width times height. So just a quick comment, do notice each small square, so this first bar, for example, does not have a width of 4. It's 4 little squares. Be careful, 10 little squares is 5. So the width of each rectangle, 4 little baby squares, means it's got a width of 2. So let's get through it. First one, this one, width of 2, height of 2.5. That's got an area of 5. Second bar has a width of 3, height of 4. That's a 12. Onto the third bar. That's got a width of 5, height of 3.4, multiplied makes 17. Fourth bar, this one, we've got a width of 5, height of 2.2, area of 11. God, that's a 17. My handwriting's embarrassing. And the final bar, E, 15 wide, 1 high, that's 15. So when you're looking for proportion, your first job is how many people do we have? The answer is 60. You can cancel it down. It might cancel down, who knows? Well, it does, because your next job is what proportion means what fraction in this place. How many people? What's the numerator? Now, if you look at this bar has an area of 15. Oh, they've made it nice. We can guess that each chunk, each third of it is 5. So how many people are above 20? It's a guess. They might not all be. They could all be 17. They could all be 29. Our guess is that they're evenly spread. There are 10 people. In other words, 1 over 6. Number 20. Again, let me advertise my website. It says give reasons. I have written it out exactly as an examiner would like to see on my website. So click the link on the video description. It'll take you to the IGCSE page, and I call them worked answers. So I've already written these out, I think, perfectly. Now I've added that line. Why have I added that line? Because it gives us triangles. Triangles mean in this one we have what's called the alternate segment theorem. So when a tangent meets the triangle ABC, we've got the alternate segment theorem, so that the angle at A is also, come on pen, is also X. Now it looks a bit wonky because it's not the standard way you'd like to see it. You normally see the alternate segment theorem. There's your angle, there's your angle, they're the same. It's easy to spot, but if you move that all the way around and have a wonky triangle over here, still works, people. So alternate segment theorem tells us that angle X is equal to angle CAB. Notice these little notches. Base angles of an isosceles triangle are equal. So that's x as well. The angle ACB is also x. So we've got two of the three angles in a triangle. So this angle at B, we don't know what it is as numerically, but we know that if we tried to find it, we'd do 180 minus the two x's. We're nearly there, folks. We haven't really brought D into play yet. Because look, let's go different colour. Does purple show up? Ish. Look what you've got here, folks. I've outlined it in purple. Opposite angles, of a cyclic quadrilateral add up to make 180. So in other words, we can say that angle ADC, ADC is 180, take away this angle we've got here. And look what happens, folks. The 180 take away 180, both disappears. And you've got minus 2x. Proof done. So basically, folks, that's a very tricky, it's a proof and circle theorems question. Yeah, it's a tricky one. You're forgiven for not getting that one. But it boils down really to it being a slightly off-centre, slightly wonky, alternate segment theorem question with a bit of isosceles triangles finishing off with a cyclic quadrilateral. It's a big boy, that. Good revision. On we go, number 21. Bit more standard, these. Line L. Don't read on, just look at line L. These questions all head off in the same direction. Start with L, find the gradient. Let's rearrange. Add 6x to both sides. What am I doing? That should be a plus 33. And to get the gradient, we want y equals 6 divided by 4 is 3 over 2. I'll use fractions now because I know what's coming. We're going to need to flip it and change the sign. But there you go. You've got the gradient. You've bagged at least a mark, maybe 2, depends on the mark scheme. But when you're told it's perpendicular, the gradient of the perpendicular is the negative reciprocal. Now, let's look at line M. How do you find the gradient between two coordinates? Well, you subtract the y's, you subtract the x's. So k minus 6 over minus 4 minus 5 is the gradient. In other words, is the gradient. And it's now come up for a third time. You've set up an equation. You've got to solve it. So I'm going to multiply both sides by 3 to get rid of that. On the bottom here, we've got negative 9. I'll multiply both sides by negative 9. And there we go. Adding 18 to both sides. K is 12. But even if you hate those questions, I've said it before, I'll say it again, at least find the gradient and at least flip it and change the sign so that you can just bank a couple of marks. Don't accept 0 for them. There's more to come. Number 22. Quite a tricky one, this. It's another one where you don't seem like you're given enough numbers. All right. But let's worry about one thing at a time. First thing I would worry about is this. They've not put that height on. All right, height is important. All right, so AB is the diameter. Well, when we talk about cones, we don't use diameters. We use the radius. So let's refer to that as R. So the area of the base of the cone, well, the base of the cone is a circle. So that's pi r squared. And that's worth 3 of something over the total surface area of the cone, which is worth 8. If you go to your formula page, the total surface area of the cone is the base of the cone, that's another pi r squared, plus pi r L. We need to stick an L on because L is referred to as the slant length. But that looks quite complicated, that. Well, pi's disappear. R's cancel out. Lots of stuff disappears. Let's multiply now. What we've got here is essentially R plus 1. That's what we've got. Let's times both sides by 8. Let's times both sides by, R plus L. I misspoke. It looks a hell of a lot simpler. Looks even more simple, and I'm going to cheat here, because I know I'm running out of room and all that malarkey. Subtract 3r from both sides. And you've now got an equation linking the radius to the length of the slant. You can either write r equals or L equals, doesn't really matter. I'll go for L equals 5/3 r. Why does that help? Let's look at the triangle. That's R. The slant is L, but it's not anymore. It's gone. It's 5/3 R. And this angle here is half the angle we want. It asks for angle AVB. So I need to double this angle I'm about to find. So 2 times, now let's focus on the right angle triangle. We've got kind of the opposite and the hypotenuse. So this is a saw. I want the angle, so it's inverse sine. Its opposite, r, divided by adjacent, 5/3 r. And here's the magic. The r's cancel, so you should just be inverse sining. Well, 5, it's 1 over 5/3. It's the reciprocal. And there we go. It wants 1 decimal place. My calc says 73.7. Don't forget you have to double it. 73.739. We'll stop at 73.7. What a doozy of a question. And finally, a vectors question without a diagram is screaming for a diagram. Now, it doesn't matter if you don't need to get it perfect. The fact is, DC is 3 lots of AB. So they're the parallel sides. Your diagram can be as terrible as mine. How wonky is that? Who cares? The fact is, AB is the smaller parallel side. It is parallel and in the same direction as DC. So that has to be labelled D. It's more about your labels than it is your diagram. So, first job, how do I get from A to B? We've got this. If I want to go from A to B, I need to think about how I get A to D and D to B. That's my journey. That way around and then that way around. Now be careful with your negatives, because what that means is A to D is opposite to that. So it's a 2 on top and a -3 on the bottom. Added, now DB is the correct way around. So we actually do know the journey from A to B. We look at corresponding elements. 2 take away 1 is 1, -3 plus 7 is 4. Why does that help? Once we've got AB, we can now treble it. DC is 3 times this. That looks important. It's 312. Now it says find the exact magnitude. We'll come back to the word magnitude. Where the heck is C? That's the question. How do we get from D to C? That's really what we're looking at. How do we get, where is C? All right. How do we find where C is? Sorry, it wants the magnitude of BC. My mistake, I was wording that a bit wrong. So how do we get from B to C? Well, let's go to D first. All right, we've already got B to D because it's the opposite of that. It's 1 minus 7. And we go from D to C. So we add on whatever we got for D to C, which means we're adding on 3/12. Which gives us a 4 on the top element and a 5, because that's a 7, by the way. My handwriting. -7 plus 12 gives us a 5. So that word magnitude, how do you find the magnitude of a vector? Well, the idea is that B to C is 4 right and 5 up. Magnitude means direct size. Yes, folks, you have to finish off with a bit of Pythagoras. It doesn't specify how the answer should be written. I left it as root 41. You could do 6 point whatever, I don't care, because that was a doozy of a paper. As you can see, it's took me nearly an hour. That must mean I've either talked too much, over-explained, mansplained, whatever, or it was quite a tough paper. I think there were plenty of good marks early on, a few good questions for revision. I did think there was some tough ones towards the end, that cone question, the cone question and this question. Quite tough. But anyway, really hope that's helped, folks, and I'll see you on the next one.